Hello everyone, welcome back to the channel. Imagine it's a Black Friday. Your company is having the biggest sales of the day of the year. Orders are pouring in every second, customers are buying products non-stop, and your dashboard glows green. Everything seems perfect at that moment. Then the payment service suddenly goes down. Not for an hour, not for a day, just for 60 seconds. Now think of it like what actually means for just 60 seconds. But thousands of customers may still be placing order during that 60 seconds. So what happens to those orders? Do customers lose them? Do we show an error and ask them to tag in later? That's not an correct experience, right? Or can we design the systems that continue operating even when parts of the architecture fails in? So today we are going to answer that question. And by the end of this video, we'll not only understand Amazon SQS, but we'll actually jump into AWS and watch it protect messages when consumers fail. So let's begin our video. So let's start with a simple example. Imagine if you are ordering a new laptop, you click place order. The order service receives your request and immediately calls the payment service. And at that exact moment, the payment service is unavailable. Maybe it's restarting, maybe some network issue, but the order service waits for a response for the payment and it didn't get the request gets timeout eventually and the user gets an error message. This is a very common problem in distributed systems. One service becomes unavailable and suddenly multiple service stops working because they are tightly connected to each other. That's the problem in a distributed system. If one service fails in, the entire downstream services also fails in. So let's introduce an SQS, simple queue service, into it. So imagine instead of having this thing directly calling the payment service, I'll introduce Amazon SQS. Instead of calling payment service directly, order service now pushes work into a queue. This changes everything. Order service no longer needs a payment service to be online. Its only responsibility is to safely store the order in the queue. Once SQS accept the message, the order is safe. That's the key behind message queues. Now let's think about what happens when you place an order on Amazon. Payments needs to be processed, the inventory needs to be updated, and analytics wants to record the purchase. Emails also needs to be sent once the order is successfully placed. And the shipping systems also needs to start preparing the delivery of that order. So basically, a single order triggers many downstream actions. So instead of directly calling every service one by one, we place work into a queue. Consumer process that work independently at their own pace. This is one of the foundation of an event-driven architecture. So let's see a live demo on how the queues are created on Amazon AWS. So I've opened the Amazon AWS console here. I'll go to the SQS part of it, simple queue service, and let's create a queue. So we'll create a queue. For now, we are keeping it a standard queue so that we can demo it easily. I'll name the queue as order queue. All the configurations we are setting leaving as default because we need a 30 seconds timeout so that we can quickly demo to you. Encryption we are disabling for now. These are the access policies. You can define your own. Other things are good. Let's create it. So now you can see the queue has been created and I've got the URL as well to add the messages in the queue. Now let's add some messages in this queue. So you can also go it with the UI as well. There is a send and receive message option. Here also I can have my message added and it will be displayed in receive messages So that is one of the way to add those messages here. So let's add it using our URL itself, which we have got. So for now, I'm adding one message which has an order ID of 104, user ID, the product name, gaming keyboard, amount, and status. So I'll send this into the queue. Now I can see the message has been sent it. I've got the message ID as well. Now let's see if the queue has received this message or not. So we need to go to send and receive messages. Now notice something interesting. We don't have a consumer running in for now. So nothing is processing these messages. So nothing is coming up here directly. We need to poll up the messages so that, let's suppose, as in consumer I polled it. So now the message has been displayed here. I can click and open this message. I can see what I have sent it as my attributes here. As the message duration we have kept as 30 seconds here, it will disappear after 30 seconds. Done. Now if we come back to the same receive message screen, at first glance it looks like the SQS deleted the message, but that's not what happened. SQS simply hides the message. This feature is called Visibility Timeout. For us it's 30 seconds. That prevents another consumer from processing the message simultaneously at the same time. So let's simulate a crash. Our consumer receives the message, but it never deletes it. Maybe the application crashed, maybe the server. Whatever the reason, processing never completed. Now what happens? Wait 30 seconds, poll the queue again, the message returns, right? I can poll it again. I have received the same message again. So that's the overall concept behind Amazon SQS, a simple queue service. And that's really the core idea behind Amazon SQS. It's not trying to prevent the failure from happening, it's accepting that failures are inevitable and creating a safe place for work to wait until systems are ready to process it. So instead of tightly coupling services together, SQS creates that separation between producers and consumers, making the entire architecture more resilient and scalable. Now we have only scratched the surface of what SQS can do. We still haven't talked about visibility timeouts, message retries, at least once delivery, or what happens when a message keeps failing over and over again. So, in the next video, we'll dive deeper into SQS and explore one of the most important reliability features in distributed systems, that is a dead letter queue or DLQ. We'll see how AWS handles that repeatedly fail messages and why DLQs are critical in production systems and how they help engineers debug issues without impacting the healthy traffic. But before we get there, let's first understand how messages actually move through an SQS queue and what happens behind the scenes when consumers start processing them. Thank you for watching this video. If you do like it, do subscribe the channel and see you in the next one.